All right, so we're going to talk about properties of special parallelograms. And your learning target is I can apply properties of rectangles, rhombuses, and squares to solve problems. All right, so let's just define a few things real quick. These are easy definitions, but a rectangle is a quadrilateral with four right angles, okay? Which we know that right angles, we know a rectangle has four right angles, okay? A rhombus is a quadrilateral with four congruent sides, okay? So a rhombus has, it's a quadrilateral with four congruent sides. It doesn't necessarily have right angles, but it has four congruent sides. And then a square is a quadrilateral with four congruent sides and four right angles, okay? So it kind of combines both the definitions of a rectangle and a rhombus. So let's go through some of those theorems about the properties of rectangles and rhombuses. And the first theorem is that a rectangle is a parallelogram. Okay, and so because we can say that a rectangle is a parallelogram, that means all of the other theorems that went along with parallelograms are true about a rectangle. Like opposite sides are going to be congruent, opposite angles are going to be congruent. The diagonals cut in half, they're going to bisect each other, right? All of those different theorems that we talked about with parallelograms are true about a rectangle. Okay, so now the second statement here, it says the diagonals in a rectangle are congruent. Okay, so this takes the diagonals thing a little bit further for rectangles. If the diagonals in a rectangle are congruent, then that means BD, line BD, has to be congruent then to line AC. Okay, so those two lines are going to be congruent to each other. Not only are they going to bisect each other, but they're going to be congruent. Okay, next we have a rhombus is a parallelogram. Okay, so again, all of the things that were true about a parallelogram are true about a rhombus. So, fourth one is that the diagonals in a rhombus, they are perpendicular. Perpendicular, and remember, perpendicular means that they cut each other at a 90-degree angle. Okay, so what that means then really is just that BD is perpendicular to AC. We're going to have right angles all the way around here. Every single one of those is going to be a right angle. I drew that really small. But all of those angles in the middle there, where they meet at the very center, those are right angles, okay? They're perpendicular. And the last one is that the diagonals in a rhombus bisect a pair of opposite angles. Okay, they bisect a pair of opposite angles. Okay, so what that means is that these angles right here, angle 1 and angle 2, those are going to be bisected so they're congruent. Angle 1 and angle 2 are congruent. It's kind of hard to see, but this is 3 and 4 for this one. Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6. Again, hard to see here. Angle 7 is congruent to angle 8. So all of these angles right here in a rhombus are going to be, they're opposite angles, they're going to be bisected. That means that they're going to be congruent. So 1 and 2 are going to be congruent. Okay, let's do some examples. Okay, example 1 says a woodworker constructs a rectangular picture frame so that JK, that's funny, is 50 centimeters. 50 centimeters for JK, and JL, this whole long length over here, is 86 centimeters. Okay, we want to know what is the value of HM, this part right here. So we need to use those things about a rectangle, those theorems about a rectangle that are true to help us solve this problem. And if what we know about a rectangle from above is that the diagonals in a rectangle are congruent. That means JL is going to be congruent to KM. Okay, so that means that JL is congruent to KM, or in other words, KM is equal to 86 centimeters, right? It has to be 86 centimeters because they're congruent. Now we know something very specific about parallelograms too, is that they bisect each other. Their diagonals are going to bisect each other, which means that KH has to be congruent to MH, right? They have to be congruent. So KH has to be congruent to MH. Okay, and we already know that KH plus KHM, both of those are going to add up to be 86, right? So essentially what we have here is a formula 2 times HM. Okay, the reason why I just put HM there is because they are the same, they're congruent. Those multiplied together or added together are going to be equal to our 86 centimeters, the whole distance of this thing. So 2 times this section is going to be 86. And if we just solve that, divide by 2 on both sides, we get that line HM then has to be equal to 43. That'll be 43 centimeters. Okay, and that's how we find what HM, the length of HM really is. So for example 2, it says that TVWX is a rhombus. We need to find each measure, and the first one we need to find is TV. Okay, TV, that's this length right here. And we know something very special about rhombuses. We know that all of the sides are congruent. Okay, that's something very specific to a rhombus. That means TX and XW and WV and VT, all 4 of those are going to be the same length. Now we know that TX is 3b plus 4 and VW is 13b minus 9. Knowing that they're going to be congruent, we can just set them equal to each other, solve for what b is, and then we would know, we could substitute that in for b and figure out the length of either one of those sides, right? So let's do that. We've got 3b plus 4 is going to be equal to 13b minus 9. Okay, this is just algebra now. We're trying to get our b's by itself, so subtract 3b from both sides. We get 4 is equal to 10b minus 9. Add 9 to both sides. 13 then is equal to 10b, and finally divide by 10, and we'll see that we get 1.3 is equal to b. 1.3 is equal to b. So if b is 1.3, we can plug 1.3 back into either one of these equations and figure out what those lines are actually equal to. And once we find out what those are equal to, we already know what VT will be then, because every single one of those sides is congruent, right? So I'm going to use the formula 3b plus 4. So 3b plus 4, and instead of b, we're going to write this as 1.3. 3 times 1.3 is just 3.9, plus 4 would mean that VT and XT and XW and WV, all of those are going to be equal to 7.9. VT is the same as TV, right? Okay, so that's going to be 7.9. Alright, now the second part, it wants us to find the measure of angle VTZ. VT and then Z. So we're looking for this little angle right here. Okay, and we know that by the definition of those rhombuses, that this angle right here is going to be the same exact thing as this angle up here, right? Those two angles are going to be congruent. We also know something else about rhombuses. We know that the right angle, each one of these is a right angle, which means that 14a plus 20 has to be equal to 90 degrees. So let's go ahead and set that up, because then we can figure out what a is worth. 14a plus 20 is equal to 90. We're just going to subtract 20 from both sides. We're left with 14a is equal to 70. And then finally divide by 14, and we get a is equal to 5. Alright, so a is equal to 5. Now we can just plug 5 in for a back into this equation up above, because this equation kind of identifies what that missing angle is, what VTZ is. So let's go ahead and 5a minus 5 and substitute 5 in for a. 5 times 5 is 25, minus 5 is just going to be 20, which means that the measure of angle VTZ is equal to 20 degrees. Alright, our last example, we're going to find the value of x for square MNOP using the properties of special right triangles. And we know with squares that all of the sides are going to be equal. Every single one of those sides is going to be equal. That means 3x plus 14 has to be equal to 5x minus 8. So again, this is somewhat easy. 3x plus 14, set it equal to 5x minus 8. We're just going to solve for x. Subtract 3x on both sides. We get 14 is equal to 2x minus 8. Add 8 to both sides. And we get 22 is equal to 2x. And finally divide by 2. And we get x is equal to 11. Which x is all we were really trying to solve for in the first place. So that's all you had to do. You just have to know the theorems for all of these special parallelograms, and then we can use those theorems in order to help us solve those problems.